And then let's take a look at the last step here. So this is fuels. This is growing some corn, growing some cellulosic products, looking at algae and so forth. But in the still bigger picture, what happens when you put those into vehicles? And here's an example. And again, on the website that Jana has set up for this particular program, we have a lot of articles, one on each one of these fuels that you can look at. So what's that top table? What that is basically looking, if you follow down the left-hand side, all the phases in making fuel. And in this particular case, it happens to be compressed natural gas. And we're going to see 6 different phases there. We're going to produce the car, we're going to assemble it, we're going to run it on natural gas, and that's the biggest number, of course, there, that 57,000. We're going to maintain the car, then we're going to get rid of the car and recycle it. So this is a hybrid electric vehicle, a Camry-sized car with a drivetrain that's like a Prius. That's what HEV would indicate in this case. And so along the bottom line in boldface, you see the numbers for the emissions, the energy use, and so forth. And then what I did is I ran 6 other varieties of Camrys. So if you look in this table at the bottom, which one of those 6, in other words, the IC engine, the HEV, the plug-in hybrid, the CNG hybrid, and so forth, based on the CO2, which is what we're talking about today, which one of those 7 varieties of Camry would you pick? Okay, CNG hybrid. So that, as I say, is just like a Prius or the current Camry, except it's using natural gas instead of gasoline, okay? And then across the next 3 columns are other types of air pollution that we track. And then what about in those last 2, or that last numerical column, the lifetime energy use, what would you pick if you were looking for the low number? Okay, FC, fuel cell. You heard about that at lunch. That's a little bit down the road. The hydrogen infrastructure is not there. The fuel cells aren't ready. But if we set that aside, then we have a close second, which is what? The third line across there? Okay, so the CNG hybrid is low, but a still lower number is actually the plug-in hybrid using gasoline, which is what's marked out here. Plug-in CNG isn't in this table. They weren't. Yeah. If we looked at a plug-in CNG value, it would be even better. And I didn't want to get too optimistic, but that's the car. But from the context of Toyota, they're not thinking about that car. These are the 7 cars that they're looking at, but maybe they should. And it's the best thing you can imagine. And the bottom line of this table, which applies for many other vehicles, is that you have to have the hybrid. You don't need the plug-in, but you've got to have the hybrid, and you also need to have the right fuel, the CNG fuel. So my life cycle analysis, which you can repeat, everything's referenced, you can use your own numbers and do it yourself, but that's the car that comes out the best. Now, why is that car so good? The reason that is not well known by the general public is that the engine in, for example, in the Prius, is a much higher efficiency gas engine than you've seen in history. It has an efficiency reported by the Society of Automotive Engineers of 38%. Well, most of our cars running on gasoline are in the high 20s, mid 20s. So you're starting with a very efficient engine. It's called an Atkinson cycle instead of an Otto cycle. So you start with that leg up, then you hybridize it, then you put CNG with it, and man, you've got a real winner here as far as the things we're looking at, which are CO2 and energy. So this is our punchline, that we want to look at the big picture. You come up with completely different answers and more correct answers if you look at everything and not just that narrow slice of the life of a vehicle, which is its drive cycle. And I think that's where I'll stop for now.
Thanks.